Okay? Let's have a look at questions 1, 2, and 4. So effectively, all I'm asking you to do is think about what each of these transformations are doing and just see where I and j end up, and then that is your new transformation matrix. It's as simple as that. So if we want to reflect in the line y equals x, then all we need to do is see where I and j end up after we reflect it in the line y equals x. Now, where is the line y equals x? Good, yeah, it's a positive gradient line which lies at 45 degrees to the axes, right? So where does I and j end up after we've reflected in the line y equals x? Who can tell me? Good, yeah, exactly, because you're happy, I gets reflected so it's up here, and j gets reflected so it's down here. That's a reflection in the line y equals x. Like, think about that as your mirror line, yeah? So I will end up going up here, okay, so where will I end up? Good. So I will end up at 0, 1. And where will j end up? Perfect. Over here at 1, 0. Is that okay? Let's do that a bit better. Is that okay? Yeah? So this matrix here would be the transformation matrix which corresponds to a reflection in the line y equals x. So in other words, if you take any point on your axis and you multiply that by this, then you will end up with the new point after it's been reflected in the line y equals x. Is that okay? Yeah? All right, fine. What about this one? Rotation 90 degrees clockwise about the origin. Okay, so where does I end up?
-1, 0.
Good, -1, 0. So I will end up at -1, 0. Good. Where will j end up?
0.
So it's like that, isn't it? It's clockwise by 90 degrees. So it's gone from that way to that way. Okay, so where will j end up? It will end up there, won't it? Can you see that? It's just basically being rotated by 90 degrees clockwise.
You're saying about from origin, yeah?
Yeah, yeah, so that's almost like, it's almost like a spinner where I'm keeping my finger fixed there and I'm just rotating him around like that. Okay? Yeah, exactly, the first one. Yeah, don't confuse that. So this is the different question. It's from this one up here, the original one. Good. Okay, so where does j end up?
J will be the 0, 1, huh? 1, 0.
1, 0, won't it? It's just one step to the right. Okay. In fact, that's the wrong way around, isn't it?
Yeah.
I should be 0, -1. Okay. So in other words, this matrix here corresponds to a rotation which is 90 degrees clockwise about the origin. Okay. Let's have a look at question 4 then. This one's slightly trickier because there's two transformations happening. We've got a stretch in the y direction by a scale factor of 2, and then we're reflecting in the x-axis. So what I've done is I've broken this up into 2. Let's get this bit done first. Let's get the stretch by a scale factor of 2 in the y direction done first. So if I'm stretching by a scale factor of 2 in the y direction, where does I end up? Where does I end up? So just do the first bit, boys. Let's do the first bit. Stretch by a y in the y direction by a scale factor of 2. Where does I end up after I've done that stretch in the y direction? So I'm picking it up and I'm going in that direction by 2.
It will be 0, 2.
No, it won't move. It won't move. In fact, I can show you on the screen. If I pick up the and do that, can you see that y hasn't moved? Y remains completely fixed. Okay, so the I remains completely fixed. Okay, so I will remain here. It's only in the y direction that this is happening. Okay, so in other words, I will remain at 1, 0. Okay. But where does j end up after I've stretched it in the y direction by a scale factor of 2? Where does j end up? 0, 2, right? So I pick him up and I've made him twice as big. Made him twice as big. So he ends up at 0, 2. You happy with that? Yeah? Because it's just the y direction this is happening in. It's different to the one where we're doing a scale factor, an enlargement, because it was happening in both the x and the y direction as well. Here, it's only happening in the y direction. So this will remain on the axis. It's just everything outside that gets stretched. Is that okay? Yeah? Okay, fine. So this is the stretch bit. Now let's think about, so this is where my I and j are now. So j is over here, and I is here, where it was before. Okay? So now let's think about the reflection in the x-axis. So what happens if I reflect this in the x-axis? It's gone like that, right? X-axis, right? X-axis, okay? So I remains fixed, doesn't move, so it stays at 1, 0, okay? But j has moved. J has gone from up here to down here. So j has gone from up here to down here, okay? Yeah, the x-axis, not the y-axis, right? So where does j end up after I've reflected him? Good, 0, -2. You remember I'm stretching this j after it's been stretched by a scale factor of 2. I'm reflecting that one, yeah? So I've stretched him first, then I'm reflecting him. He ends up down here. So finally, this matrix here will correspond to both of these transformations. In other words, if you take a coordinate matrix and multiply by this matrix, then you will end up with the new coordinates which correspond to the transformation stretched by a y direction scale factor 2 and then reflecting it in the x-axis. Okay.